Welcome to the SmartKeys podcast.
Great to be here.
Today, we are undertaking a deep dive into what is, well, arguably the most critical and complex financial subject facing every scaling tech business right now.
Cloud cost optimization, CCO.
Exactly, CCO. And the conversation has officially moved out of the IT department and squarely into the executive suite. The bills are soaring, that's clear.
Oh, yeah.
But the strategic question you have to ask is, are those costs rising because you're successfully scaling and growing revenue, or are they rising because you're simply wasting resources?
And that distinction, growth versus waste, that is the single most crucial factor for modern digital businesses. And the stakes couldn't be higher.
Right.
I mean, based on the source material we analyzed, the data is stark. Many organizations are wasting an astounding 32% of their total cloud budgets.
32%, that's huge.
It's massive. And why is this happening today more than ever? It's not usually malicious. It's a systemic lack of visibility. Modern complex architectures. Think high-velocity microservices, serverless components, and these sprawling Kubernetes deployments. They're designed for engineering speed.
Sure, for agility.
But they often hide exactly where those costs are actually appearing and who should be accountable for them. Our mission today is to flip that script.
So ensuring your rising cloud bill is viewed as an investment that reflects true business value.
Not just infrastructure and efficiency.
Exactly.
Okay, let's unpack this strategic shift then. We are emphatically not talking about the kind of blunt, across-the-board cost-cutting that, as we know, can immediately hurt development velocity.
Oh, it kills innovation.
It slows everything down. It can degrade the user experience. This deep dive is about turning cloud spending management into a core strategic business conversation.
Yes.
To do that, we need a clear, rigorous roadmap that links every dollar spent in the cloud directly to product metrics, customer growth, and quantifiable business outcomes. Exactly. And that strategic linkage starts by abandoning the traditional view of optimization and just changing how we measure success.
And here's where the data gets strategically useful.
The essential shift is moving away from focusing solely on raw monthly totals, that big, scary, easily digestible number on the invoice.
The one that makes the CFO panic.
That's the one. And moving toward what the sources refer to as unit economics. This is the fundamental difference between measuring total organizational spend and measuring your actual cost per customer.
Or per feature delivered, per environment.
Exactly, per anything that actually matters to the business.
I think this is a huge hurdle for finance teams, but it's critical for engineering alignment. So why does relying only on that total monthly bill lead to such poor decisions?
Because without the unit view, any higher expenditure always looks like a problem.
Right.
Even when it's genuinely supporting rapid, successful product-led expansion. For example, if your total cloud bill increased by 20% last quarter, a CFO might panic. But if your cost per daily active user dropped by 10% in that same period, your efficiency is actually improving dramatically at scale.
So that 20% increase is actually a signal of healthy growth.
It's exactly that. Unit economics gives you the context you need to judge true value.
That makes perfect sense. So if we're tracking unit costs, what are the clear signals that tell a company its rising bill is healthy versus one that signals systemic waste?
The healthy spend is always signaled when your unit metrics improve. We look for a higher gross margin per user or a lower cost per deployed feature.
Which means your architecture is becoming more financially efficient at scale.
Precisely. The waste signal, conversely, is the red flag we want to catch immediately. That's when usage rises dramatically. Say, you have a sudden spike in data storage or compute hours.
But there's no business reason for it.
Exactly. You see zero corresponding customer lift, zero revenue growth, or zero positive movement in those core business metrics. That often signals a hidden workload, an unattached resource.
Or some over-provisioned service that has no current business owner.
You got it.
And focusing on those signals allows us to immediately address the most controllable drivers of rising costs. We're talking about the low-hanging fruit for waste elimination. What are the engineering teams consistently missing?
Well, the sources outline a few critical common areas. First, idle or unattached instances.
The ones left running after a test.
Exactly. After tests, proofs of concept experiments are finished. These are the forgotten children of the cloud, happily racking up, cost 24/7.
And then there's oversized storage.
Right, storage that was provisioned too aggressively because an engineer needed to meet some theoretical peak load that rarely, if ever, occurs.
And what else?
Verbose logging. trace data that is consuming massive unnecessary space because retention policies were never set, and of course, underutilized VMs running an 8-core instance when a 4-core would suffice.
So the immediate actionable steps here are pretty clear.
Very clear. You have to implement continuous automated cleanup sweeps for those unused resources and implement data-driven right-sizing to optimize the infrastructure you are using.
So, synthesizing this, the core definition of true cloud cost optimization is matching the right compute, storage, and services to each specific workload
Yes.
to meet performance, security, and compliance targets, all while meticulously eliminating and avoiding waste. It's a targeted, clinical approach.
It's a scalpel, not a machete.
Right, not a blunt machete cut approach.
Precisely. Because if you cut without context, you hurt development, velocity, and customer experience. True CCO is strategic matching, which starts with knowing exactly where every penny is going.
Speaking of knowing where every penny is going, let's move into the necessity of visibility. You can't optimize what you can't see.
You really can.
So visibility turns that raw billing statement into a strategic prioritization tool. Why is real-time data and hourly allocation so crucial here compared to simply waiting for the monthly invoice?
Waiting for the invoice is like reading yesterday's newspaper to trade stocks. It's too late.
The damage is done.
It is. If you only rely on daily batch reports, you are missing short-lived anomalies. A massive data transfer job that ran for 2 hours overnight, for example.
And that can eat away a significant part of your budget before anyone even notices.
It really can. Hourly or real-time allocation surfaces these spikes immediately. This is the difference between catching an errant job and losing 5 figures before the end of the week.
So the engineer who wrote the code can fix the root cause immediately.
Right, not days or weeks later when the damage is compounded.
That brings up the significant allocation challenge. Modern companies aren't running simple monoliths on a single provider anymore.
Oh, not at all.
We're talking Kubernetes orchestration, we're talking specialized data platforms like Snowflake and Databricks, and often multiple providers like Google Cloud, AWS, or Azure. How do you practically unify that disparate spend?
Into one actionable pane that engineers actually trust.
Yeah.
It absolutely requires strong tagging and governance enforcement. Tags must be tied explicitly to teams, environments, and product IDs.
Tags are the foundation.
They're everything. If you have great tags, allocation becomes automatic. But the technical challenge is getting all those platforms, Kubernetes pods, shared data warehouse compute, and standard VMs to report costs using these same tags and metadata.
Then you pair that reliable allocation with showback or chargeback dashboards.
Dashboards that engineers trust so they can see the direct cost impact of their code choices in real time. Without this unified, accurate allocation, you simply cannot calculate true unit economics across your diverse stack.
That's a powerful point. When teams have accurate allocation via tagging, they immediately ask, how do we control this?
Exactly.
And that's where strong governance comes in. It sounds restrictive, but the governance framework acts as a set of guardrails.
Right. It keeps your teams fast, accountable, and aligned with business goals.
How so?
Well, the key is establishing meaningful budgets that reflect product packaging and SLAs, not just arbitrary numbers pulled out of thin air.
Okay, so give me an example.
For example, the budget for a public free trial tier should be radically different and accept a higher risk of interruption than the budget for a high-availability, mission-critical enterprise offering.
So you're tying day-to-day spending choices directly to revenue expectations and service-level agreements.
You got it. And that, in turn, helps eliminate the dreaded shadow cloud.
The what?
Shadow cloud. It's a constant drain happening when forgotten resources live in hidden or unmanaged accounts.
We've all been there.
Oh, yeah. A forgotten staging environment for a product that was killed 9 months ago, still happily racking up fees.
So you stop this by standardizing ownership tags, making them mandatory.
And separating accounts or projects for different cost centers. The source material had a great quote that sums this up. When every resource maps to a business metric, decisions become measurable and repeatable.
That's good.
And you pair those mandatory tags and meaningful budgets with proactive alerts and lightweight governance tools to flag overspend early.
Let's talk mechanics. When we're looking at advanced optimization levers, we've covered the general cleanup, but what should that formal, repeatable, weekly hygiene sweep look like for the engineering team?
It needs to be a repeatable scan, tag, and act process that is automated as much as possible.
The goal being to catch the most egregious waste before the bill is even generated.
Exactly. We're talking about identifying unattached disks, idle instances, and orphan snapshots resources you are provisioning and paying for but doing absolutely nothing with.
And then you automate the safe deletion or termination of these low utilization items.
Right. And it's important to use native cloud provider tools like CloudWatch, Cost Explorer, or the Azure Cost Management Suite.
But the sources also recommend validating those findings with specialized third-party tools.
They do, like Densify, Vertana, or Cloudability.
Why use a third-party tool if the cloud provider gives you the data?
Because these specialized tools don't just look at basic utilization. They provide complex modeling and simulation of what would happen if you moved from, say, an M5.large to an M5.x large, factoring in peak lows and risk.
So they move beyond simple observation.
Yes, to deliver validated, executable recommendations, which is a crucial step beyond just native reports.
And once that obvious waste is gone, we get to the core right-sizing challenge. How do you scale down an over-provisioned instance without accidentally breaking performance or reliability? That's where engineering teams usually get nervous.
Right-sizing has to be strictly data-driven to eliminate that nervousness. You have to set precise thresholds on CPU, memory, and I/O utilization over a statistically significant period.
So you have real data to back up the decision.
Right. If the usage data consistently shows an instance is significantly over-provisioned, say running at 5% CPU capacity most of the time, you can safely downshift it.
Okay.
Critically, many of these automated recommendations should be funneled directly into pull requests or change requests within the existing development workflow.
Oh, that's smart. So it keeps the engineers in control.
It keeps them in control of the final decision and preserves their confidence, which, as you mentioned, is key to preserving velocity.
That's the key, preserving velocity. Now, moving beyond the physical size of the resource, let's talk about strategic pricing levers.
Okay.
This is where you classify your workload. Is it steady, spiky, or fault-tolerant? And match the pricing structure accordingly. We hear a lot about reserved instances and savings plans. What's the difference?
This is a massive opportunity for savings. Both reserved instances, RISE, and savings plans, SPS, offer substantial discounts.
Sometimes up to 75%.
Yeah, based on a 1 or 3 year commitment. You choose reserved instances for stable, long-running services where you have maximum predictability.
Like database instances or specific fixed compute needs.
Exactly. RISE are highly specific. You opt for savings plans when you need flexibility. SPs commit to a dollar amount of hourly spend rather than a specific instance type. This is ideal for organizations using many different instance families or those that frequently move between different regions.
So it's about predictability versus portability.
That's a great way to put it.
And then there are the deeply discounted but interruptible options.
That's the domain of spot instances. These are spare capacity that the cloud provider offers at massive discounts, sometimes 80% off the on-demand price.
But they can be taken away at any moment.
With very little notice, yes. So they are perfect for workloads that can tolerate unexpected restarts, like batch processing, large-scale machine learning training jobs, or CI pipelines.
So for fault-tolerant or non-critical jobs, spot instances can drastically shrink your bill.
Provided you use careful orchestration and automation tools to manage the risk of interruption. You match the risk to the reward.
We can't forget the insidious hidden fees often tied to storage and especially network egress.
Ugh, the transfer costs.
They always sneak up on finance and often surprise engineers.
They absolutely do. Storage is manageable if you use intelligent tiering. The goal here is to match the right storage tier to the data's access frequency.
Use lifecycle policies.
Right, and intelligent tiering like S3 intelligent tiering, which analyzes access patterns and automatically moves cold data to cheaper archival tiers.
But the biggest hidden cost is network egress.
And inter-region transfer. We often forget that moving data between availability zones, even within the same region, can carry a cost.
So you have to architect for it.
You must. You architect your solution to limit data transfer by design, keeping chatty services and their corresponding data co-located to minimize that expensive traffic.
This brings us to a crucial forward-looking concept, shifting left in the software development lifecycle.
The SDLC, yes.
We typically think of cost optimization as something you do after deployment, when the bill arrives.
When it's too late.
But the source material suggests the biggest, most sustainable gains come when you bake cost visibility and control into the design process itself.
That's right. Preventing waste is always cheaper than remediation. Shifting left means designing for elasticity using auto-scaling, containers, and serverless patterns.
So infrastructure only scales with actual demand, not theoretical maximums.
Exactly. We're embedding cost awareness into the developer workflow. One immediate, high-impact, practical win here is automating environment hibernation.
Explain that, because if development stops when the budget is reached, that hurts velocity.
It's not stopping development, it's stopping waste. Simply setting policies to automatically shut down or tear down non-critical dev and test environments each night and on weekends,
That cuts recurring, steady-state waste dramatically.
without hurting daytime productivity at all. It's a fundamental change in the team's workflow and culture that shows massive ROI instantly.
And when those resources are running, we need real-time monitoring to catch anomalies immediately because, as you mentioned, minutes matter. What role does machine learning play here?
The static alerts just generate too much noise. People start ignoring them.
Alert fatigue.
Right. ML models are essential because they learn what normal behavior looks like for your specific environment. They recognize baseline patterns.
So a spike in CPU at 3 p.m. on a Tuesday is normal.
But a spike at 3 a.m. on a Sunday is not. This drastically reduces noise, allowing you to catch errant jobs or runaway instances within hours instead of days.
And you get proactive, actionable notifications.
That's send context. Which resource changed, who owns it, the estimated cost impact, and you can wire those signals to automated policies that can pause or scale down non-critical workloads before the spike compounds.
It all rolls up into continuous improvement. What KPIs should teams be tracking to measure success beyond just the raw dollar savings at the end of the month?
You have to track business-aligned KPIs. Focus on the improvement of your cost per customer.
And the direct gross margin impact.
Yes, utilization rates and the accuracy of your financial forecasts. The goal is to make CCO a measurable, repeatable process.
And speaking of measurable success, the sources highlighted some powerful examples.
They did. Tools need visibility depth, allocation accuracy, and strong usability. It was noted that a focus on unit economics and real-time monitoring helped one company, Drift, save $4 million.
Wow. That's the power of tying metrics to outcomes.
That's the difference between cost-cutting and strategic scaling.
Ultimately, optimization is a continuous feedback loop. You predict future spend, you monitor current usage, and you adjust your architecture and commitments accordingly.
And the ultimate outcome is ensuring that you can scale your wins and keep investing in the features your customers love without having that investment erode your hard-won margins.
The forecast isn't just a prediction.
It's the starting point for the next cycle of optimization. Absolutely.
That's fantastic. We've covered everything from unit economics and governance guardrails to strategic commitments and machine learning anomaly detection. So here's a final provocative thought for you, the listener, to apply this knowledge immediately. Think about the strategic pricing levers we discussed: reserved instances, savings plans, and spot. What specific workload in your organization, be it steady, spiky, or fault-tolerant, is currently running on the default, most expensive on-demand pricing structure?
There's always one.
Start there. Identify that workload and see if you can move it to a more appropriate commitment model this week.
A great actionable place to begin.
Thank you for tuning in to the SmartKeys podcast. We hope this deep dive helps you move cloud cost optimization from a necessary technical hassle to a core business strategy that impacts your bottom line.
We really do.
The full article we discussed today, Cloud Cost Optimization Strategies for Tech Companies of All Sizes by Felix Römer, is linked in the show notes. Be sure to subscribe for future deep dives into the strategies that shaped the future of business efficiency.